Hi everybody, so this is a lesson on systems of equations with subscripted variables, and I just want to point out that the system of equations for each of these sets here, there are four systems, or four equations rather, in each system. And so if you look at this first set, you have r sub a, t sub a, plus r sub p, t sub p equals 320. And then on the right, you have these additional equations here where you have r sub p equals 50 and t sub p equals 4 and t sub a equals 3. So what we're trying to do here is we are trying to figure out the values of each of these variables. Now what's really handy about this first one is that we actually have the value of each of these variables built into 3 out of the 4 of the equations. So what we're going to do is that we're going to take the information here on the right, where I've kind of put this marking, and we're going to substitute each of these values for their given subscripted variables within this equation here. So what we're going to do is that we find out that the only one that we do not currently have is r sub a. So that's what we're going to be solving for. We do have t sub a, though. That's 3. We have r sub p, which is 50, and we have t sub p, which is 4. And with that, we have exactly what we want, which is an equation that only has one unknown, which is r sub a. And so we're going to solve this just like we would solve any other equation. So I'm going to go ahead and do that. And what I got was r sub a is equal to 40. And so now I've got to just check, yes, I have the value of r sub a, and I have the value of the others up here already. So I'm all set. Okay, so let's look at this second example. So the second example here is maybe a little bit more complicated because we don't exactly have all of the values of our 4 variables within our 4 equation system. But let's see what we do have here. So we have kind of the what I would call the more complicated equation over here, and then we have some information here on the right. We have r sub t equals 2, r sub r equals 10, and t sub t equals tr. Now, if we kind of notice over here on the left, we actually have quite a lot of information here, and the goal really for me is to take the equation that I've circled and get it so that it only has one variable that we can then solve. So let's see. So we have r sub t, that's 2, so I'm going to substitute that in. We have t sub t is equal to tr. That's really useful because that means that we can actually take t sub t and substitute tr for t sub t if they're actually equivalent to each other. Now, why would I want to do that? Well, because I don't know what tr is and I don't know what t sub t is, but if I have just a t sub r in this equation, then what I can do is I can just have that one t sub r in there that I can solve for. So what I've done is that I have substituted in t sub r for t sub t. R sub r I have a value for, which is 10, but then I'm just going to leave this t sub r. Now, I could have very easily have substituted t sub t for t sub r, but I chose to substitute t sub r for t sub t. Whichever way you'd want to do it is fine, as long as you end up with an equation like I have, where I only have one variable. In this case, it's t sub r. So what I'm going to do now is I'm going to solve this. I'm going to subtract 2 t sub r from each side. And I end up with 120 equals 8 t sub r. And then I can divide each side by 8 to solve for t sub r. And here we go. So I have t sub r is equal to 15. And now what I need to know then is that if I know that t sub r is equal to 15, then I also know that t sub t is equal to 15 because t sub t is equal to t sub r. So the information that I have then is t sub r is equal to 15, t sub t is equal to 15, and I've got the value of all four variables up here. Give this a shot. Just kidding, we have another one on the next page. All right, so once again, we have a system of four equations, and we actually have four variables within that system. Luckily, we have a value of two of those variables. R sub L is 40 and R sub S is 80. And our job is to figure out what T sub L and T sub S is. So one of the things that I'm going to do here is I'm going to take this equation that I've circled and I'm going to go ahead and put as much information as I can as possible, with the goal being to have an equation that only has one variable, just like with the last one. So R sub L is 40, so I'm going to substitute 40 in for R sub L. I don't know what T sub L is, and I guess I could solve T sub L on the right, but I'm not going to. Because it would be more trouble than it's worth. R sub S is 80. And what I am going to do is I'm going to take T sub S and I'm going to substitute T sub S with TL minus 5. And the reason that I'm going to do that is because now I have an equation where I can solve for T sub L. So I'm going to go ahead and do that now. So I got T sub L equals 10. And now if I know that T sub L is equal to 10, what I can do is I can substitute 10 in for T sub L in this little equation to figure out what T sub S is. So I'm going to do that. T sub S is equal to 10 minus 5. And so we get that T sub S is equal to 5. Now give these a shot.